All right. Morning. All right. Morning, everyone. Just before we get into the lectures, hopefully you guys have all seen that assignment 2 is out now. So it is. Has anyone had a chance to read it? Mm-hmm. Yes, some. Has everyone had a chance to read it? Yeah, well, close enough anyway. Okay, so yeah, just to recap, basically we're going to be doing software prototyping for a virtual reality training simulator in Unity. I know we haven't spent a lot of time looking specifically at Unity so far, but we'll be covering it over the next 2, maybe 3 lectures anyway, and certainly we'll be covering everything that you guys will need to know for this, other than maybe some little things that you will either have to figure out yourself or you can ask me if you get stuck. But basically the assignment is broken down into, I think it was 4 parts, wasn't it? Yep, 4 parts. So part 1 is basically an interaction and graphics part. So putting some stuff on the screen and making it interactable. So we are having 2 objects. One will be a opaque, so non-see-through object, so it could just be a box, like a cube or something if you wanted, and then you'll have the same shape but semi-transparent. And the idea is in this that we're talking about very early days of or very, very sort of proof of concept-y of a software prototyping for virtual reality training. And you could imagine maybe I'm doing something where I'm doing aircraft repairs and I have to, see, okay, I need to put a rivet in the aircraft hull there, so I see like a little transparent thing showing where I need to put the rivet or the tool, and I just have to move that tool up there to confirm that yes, I've done it. So what we're going to be doing is something a sort of very basic version of that sort of idea. And when I say basic, is as basic as you want to do it, because part 4 of the assignment is to take it beyond the requirements. So you're more than welcome, if you really love it, to keep going. So yeah, the first one, you have 2 objects, a real object and what we've called a ghost object. And the user controls the real object in X, Y, and Z positions. So X, Y, or Y and Z. And the idea is that the user should be able to move the real object using the keyboard keys A, D, W, S, I, and J to move it back and forth along those 3 axes, and then eventually line it up with the ghost object. And when the task is when the real object is within some tolerance, so it's close enough, the task is considered complete. And then we move the ghost object and the user has to move the real object to the new position. And the idea is, you do it, move it to here, and then it would appear somewhere else, and you move it there, and then it appears somewhere else, move it around. So for the first task, create 2 objects, one with opaque material, one with transparent. Allow the user to control the opaque object with those keys. Randomly choose a position for the transparent object and check to see whether the real object and the transparent object are within a certain distance, and if so, restart the simulation. Part 2 is adding some UI and some logic. So this is UI and a bit more programming. So you're going to have a UI with a minimum of a text box which will show some statistics and a button to clear the statistics, and a script which will keep some track of things which are happening in the scene. So for example, you need to keep track of since the user has started the application or last clicked the button, how many times they've successfully moved the real object to the ghost object, and also keep a track of how long it's taken them to do that for at least the last 3 times. So yeah, we're basically from when you start it to when they complete it, how long does that take? And then you restart, and how long does that take? And you need to be able to show that in the text box for the last 3 times. Yeah, so you're going to write a little bit of logic and put some GUI stuff and hook them together. Part 3 then is looking at some more graphic stuff, so looking into camera, so you're going to need to be able to control the camera in 2 dimensions, so changing its view left to right and up and down, or yaw and roll as they're commonly known, using the mouse. So we move the mouse left to right and the camera turns left to right, we move the camera up and down, and it moves up and down. We're not too worried about roll, which is that way in this case. And then we're going to swap out the primitive that you've used. So if you've used a cube or whatever, we're going to swap that out for what's known as a prefab, which is a way that Unity uses, Unity allows you to encapsulate a game object and the scripts attached and stuff, like sort of save it out so you can create it later. And you'll be replacing your prefab, be it a cube or whatever from version 1 with the primitive objects, you'll be replacing it with your prefabs, and you should have at least 3. So I don't care which 3 you use, you could just use the primitives again, cubes for your capsule, or you could perhaps go on the Unity asset store and download something. So I used, the example is the ghost bat and the slime from that monsters pack we have. Doesn't really matter as long as you have, it will randomly choose between the 3 prefabs at any point in time. So to summarize the tasks: controlling the camera with the mouse, the X and Y to rotate side to side and up and down, and changing your code to load or instantiate a prefab for each task, and it will randomly select between the 3. And so each of those first 3 parts are worth 30% of the total assignment mark. And then part 4 is to add some flair. So that will be you guys doing something which is of interest to you to just make it a bit more exciting. So you could be adding sound effects and music. So when you finish a task, it plays a little celebration noise, or when something happens, it makes various sound effects. You could play around with some lighting to make it a little bit more interesting. Lights turn on when you succeed or whatever. Tweak the user interface, modify your application to run on mobile. So you could have it that it's a mobile app and you click and drag to move the thing around. And you could even use the gyro on the thing rather than turning the camera with the mouse. You turn the object and that will change the view. So moving towards VR. And this is a little bit more sort of abstract in that, I will basically be awarding it based on, how much impact it is. So if you put one image on your UI, that probably won't give you full marks. But if you manage to get it running on the mobile device, you'll probably get full marks for that section. Like, as I described, like, so it turns, the head turns with the gyro of the device and stuff, that will probably be worth full marks. If you do want to just tweak the UI, probably do more than just adding an image, something which looks like it's probably taken a little bit of effort to make it look nicer rather than just the bare minimum. I noticed a spelling mistake. That shouldn't be the report. That should be your assignment is due Friday, 10th of May, which I think from when I made this live last Friday gave 1, 2, 3, 4, 5 weeks to do. So there is, I think those 2 weeks in there this week is Easter, so there'll be no lectures, no lectures on in this week, and I think this is another thesis week. So you basically got from there 2 full weeks and then another full week of class time to get this done. So, ideally you can probably get this whole assignment knocked out in a couple of weeks. So if you start working on it soon, you could probably get it finished before the Easter break anyway. So I wanted to make sure that you don't have to work over the Easter break, because nobody wants to do that. Cool, and the assignment is worth 10% of the grade for MHIT 603. So I think the last one was worth, yeah, that might actually supposed to be, I have to double check that. It might actually be 15%. I can't remember this.
Last one was 10.
Yeah, I think last one was supposed to be 10, and this one and the next one is supposed to be 15. Sorry, I took that from last time where we used to have 4 assignments. So I'll double check that, but the breakdown of grades will still be the same. It's just what that is worth, because I think, I'll have to double check, but I think we changed the thing so that the projects are worth 60% and the assignments are worth 40%. So the project week will, have you guys already had one project week? No, I think maybe that's after the week after Easter, and then there'll be another 3 at the end. So the project weeks, there's no lectures or anything on either. So they'll be worth 60%. And I think the 3 assignments that you'll be getting, so the one you've already done, which is my job to mark this week, And this one and the one Niels will give you will be worth 40% of the grade for 603. Cool. Any questions? No, everyone's happy at this point in time. If you do have any questions, feel free to drop me an email. If it's a good question, I'll anonymize it and then send it and my response out to the class as well. So, because there's bound to have been stuff. This is the first time we've done an assignment in Unity, so there's bound to be stuff in there that I have overlooked that I should have said that I haven't. So please don't feel like you're stupid or whatever. If you have a question, chances are it's actually my fault that I have neglected to mention something. Okay, cool. Oh, actually, the only other thing. So I've put it so you can upload onto Learn, but I think Learn has a 256 megabyte limit. So worst case, stick it on Drop Zone. So for those of you who don't remember, Drop Zone is a special server which is running on the lab if you're on a Mac. If you go into Finder and then go connect to server and type in smb:// it'll FS. So for HitLab file server and go connect, then that will eventually connect to the HitLab file server and you see, select the list of volumes you want to mount on HitLFS and you'll see in there is drop zone. And so what you could do is just create a folder with your name in it. So you'll see there's a bunch of folders for different people. Create a folder with your name in it, put your assignment in there, and then just send me an email or on Learn or whatever. Just, upload a text file or something saying my assignment is in HitLFS/whatever, so I can find it. Or put it on Dropbox or give it to me on a USB, whatever, I don't care. We can figure something out. Okay, cool. Otherwise, if no one has any other questions, let's move forward. So last week we finished off with our 3D graphic stuff. And so this week we're going to be returning to Unity to look at some of the stuff. So we looked at Unity already about what it is, and we've ran through the entire graphics section, comparing that with how stuff works in processing versus how stuff works in Unity. And so this week we're going to be looking at a little bit more depth into programming in Unity primarily. A quick reminder, the Unity editor has a bunch of different windows. Scene and game we've been looking at a lot. Project is the file system that, it's in there somewhere. Project is the file system that all your assets and stuff are stored in. Hierarchy is the scene graph that shows the relationship between all the various, sorry, this is being a bit annoying, all the various items in your scene. Then you have the inspector, which shows the game objects, which are, or the components which are attached to various game objects, and the console we haven't really talked about yet, but we will be talking about that today. Okay. I knew there was something I need to update on here. So Unity supports C#. I have a feeling it may still support JavaScript, but certainly that is nowhere near as popular as it used to be. So we're just going to be focusing on C# for the moment. So C# is a language which was sort of spearheaded by Microsoft as their attempt to bring the C language sort of more up to line with Java. So processing runs on top of Java, so if you know processing, you can write Java, and if you can write Java, you can write C, because Java was basically based on C. Then there's also C++, which was sort of the first attempt to make C more object-oriented, so we've talked about object-oriented programming. And C# was sort of a ground-up redesign of it by Microsoft, because a lot of people say that C++ was sort of a really hacky way of object-oriented programming and a bunch of other stuff, niceties. So C first came out, I think, in the late 1970s, and so obviously it's pretty old, and then a bunch of better languages came out, but C was still so popular that they're like, oh, well, let's make C++, and I think sort of the early versions of that were mid-80s, early 90s. but it was really sort of tacking on a whole bunch of new stuff to a really old language. So the equivalent of putting a really fancy engine in a really old crappy car. So eventually, Microsoft said, well, let's actually just do a ground up rebuild, and did it on C#. And C# is actually quite a nice language. Does a lot of it still sticks with the C syntax and C style, which if you know Java and processing, it's pretty similar. But it does a lot of things better than C and C++ and makes life a lot easier. Actually, that's no longer in date either. So when we downloaded processing and installed it, one of the options was what development environment we wanted to use. And I think by default, the new version, or from 2018 onwards, it now comes bundled with Visual Studio. So let's start a new scene, and I'm going to create a new script. Actually, let's just open that one for the meantime. So if I've created a new screen and I want to create a script, all I need to do is right-click down here in my project and go Create C# script. Or alternately, what I can do is say I have a certain object, so my cube here, and I want to attach a new component to it as a script. I can click on Add Component, and we can see in here we've got a list of all the components. Or if I just start typing and it doesn't know what I'm talking about, you'll see it pops up with the idea of new script, and I can click on that and then give it a name and hit Create and Add. And that will create, you can see in here, it's created the script My Cube controller, and it's also attached that script as a component to my cube over here. Okay, so while that's going, this is slowly opening in the background. So this is Visual Studio Community, which I use. I have a feeling they use something, oh no, maybe it is Visual Studio Community on on Mac by default. I think it's something different. I think it's just Visual Studio on Windows. You can actually use any editor you want for this. So I used Visual Studio, used to be Monodevelop, and then I used Visual Studio Code for a while because Monodevelop was super slow on my laptop. And then they made Visual Studio Community the official one. So you can actually change it to whatever editor you're happy with, but we're just going to be focusing on using the Visual Studio stuff in class because that's what comes by default. So the way it works is it's basically like processing in that it's just a text editor, but it's got a bunch of stuff like autocomplete that processing doesn't have, which is kind of nice. Yeah, so let's get started. So if I double click on my cube controller here, you'll see that this is going to open up my cube controller, and likewise in the solution on the side we can see the same thing in the solution as in my project folder down here. So we have the assets directory, and then we have a bunch of other things: animal, killer whale, level 1 monster pack, etc. And when we go into a folder, we can see the script. So .cs stands for C#. I'll close all these down before I get bombarded with notifications. And you can see in here we've got two C# files, the dog one, which was the one we downloaded the other day from Unity's April Fool's thing, and my cube controller, which by default, if you add a component, it'll just stick it in the root of your assets folder. And so you can see over here, dog and my cube component in there. Let me see if I can change. There we go, make that a bit bigger. So this is what a script by default looks like in Unity. So there's a bunch of stuff up the top which it says using systems collections generic, using the Unity engines. And what that is it's like in processing how we had the import statements. So, when we use Control P5, the graphics library would say import Control P5. So basically these are a collection of libraries that we have that we can use code from, and basically Unity, by default Unity will give you a few of them which are probably quite handy. So system collections and system collections generic are basically a bunch of different containers for data types. So we've talked about arrays before. One really common one that you might like to use, which system.collections.generic provides, is what's known as a list. And a list is like an array, but you can add and remove things to it. You don't have to say, so if you remember from an array, we said make an array of 5 somethings, and then it was set at 5 and you're stuck with 5. Whereas a list, you can just say create a new list, and then you can say stick this in the list, stick that in the list, and so on. And for most other things, it behaves like an array, but you can add and remove things to it, which is really handy. And we talked about stacks when we talked about push and pop. So stacks are part of the system collections generic namespace as well. And then we have using Unity Engine. So Unity Engine basically provides a bunch of scripts or code rather that Unity provides that we can use to control our Unity classes. So you don't have to worry too much about these things, just leave them up the top and they're not going to do any harm. But if you remove them, you might lose access to some things like lists. If you remove the Unity Engine, you probably lose access to a lot of stuff. So you probably want to leave that one in there. Okay. Then we have public class. So don't worry so much about the public. It just means that all other classes can access it. Class is the same as in processing. And then we have the name of our class, again, like in processing. So I called my class myCubeController. It's created a file called myCubeController.cs. We can see it in my Finder right there. And the only thing is that you should do this anyway, but your class should reflect the name of the file. But this is especially important in Unity for components, because if your class has a different name than the file does, it won't work properly as a component. So for example, if I change this to myCubeController2 and save it, once this finishes recompiling, you'll notice that this now says script. The associated script cannot be loaded. Please fix any compiler errors. So if you see this appear on your thing, chances are that the name of the script, or the name of the class is different from the name of the file that it's in. So just make sure those two things match, and then it should pop up as a script which has been attached to my CubeController. Okay, then the next thing is this : monobehaviour. So we talked a little bit about inheritance in processing. So we said we could say that we have a class of type human, and all humans can eat and sleep and talk. And then we have a class of student, which inherits off person. And so a student can do everything a person can do, and they can also do some other things. And likewise, we have a lecturer, and a lecturer inherits off a person. So a lecturer can also do everything that a person can do, but they can do some other things. And this is exactly the same thing here. So what this : monobehaviour is saying is that my CubeController is a type of a monobehaviour. So it can do everything what a monobehaviour can do, and it can do some other things. And we'll talk about what a monobehaviour can do in a minute. And then inside our class, we have two functions which are provided for us by default. The start function, which, as it says in the comments, start is called before the first frame update. So it gets called at the start of when we first start running our application, and update, which gets called once per frame. So this is like the start function in processing, and this is like the draw function in processing. They pretty much work in exactly the same ways. So let's put some code in here. So in processing, we had printf. In Unity, what we do is we say debug.log. So debug is a special class that allows us to write stuff to the console down here, and .log just means write a regular message. And then I can put my message as a string. This is the start function. And if I save that, we go back. So in our scene now, we have a cube, and our cube has this CubeController attached to it. And if I hit run, you'll see in my console window down here, this is the start function. And if I click on that, we can see that this is the start function, was called by unity.debug.log, and that in turn was called by myCubeController.start, which is at assets myCubeController CS and line 10. And sure enough, on line 10, there is that line of code. So that's quite, like, having that sort of level of detail, like it shows us where the stuff came from, is really handy, because if we have lots and lots of different scripts running and they're all printing stuff, I can see very quickly. What I can also do is I can actually double click on that, and that'll take me directly to where it was. So it's a really powerful way of debugging that we can just double click on it and go exactly to the script where it was written. Okay, so that's the start method. So let's have a look at update. This is the update function. And if we run this now, we'll see very quickly this is filling up with tons and tons of this is the update method. So once a frame, that's going to fill up. We do still have a start function right at the very top because that gets called at the very start, and then all the update functions appear underneath that. So what I could do is if I wanted, well, let's say I wanted to see that start function. It's a little bit hard to find. Or actually, let's do another one. I might create another script, my other cube controller. New script. So we're going to create two scripts now, my cube controller and my other cube controller. So this one will be a completely separate script. Other cube, controller update. So now we have these two scripts on here, and both of them have a start function and both of them have an update function, although my other cube controller, only the update function does something. So that actually doesn't matter that we have two scripts attached to the same game object which have the same function, because as far as Unity is concerned, these two scripts operate independent of each other. So both of their start functions will be called and both of their update functions will be called. So if I run this again now, we'll see we've only got the one start function, which is in my cube controller because nothing happens in the other one. And then we'll see my other cube controller update gets called, and then this is the update function. And then my other cube controller, this is the update, my other cube. So they're both being called one after the other over and over and over again. So one thing which is kind of handy, obviously this is kind of hard to see which of these scripts, or which of these debug things is coming from which script without actually reading them. So what I might like to do is actually code them so I can see them a bit easier. So I mentioned before that debug log is a special function. So debug is a class which allows us to write stuff to our console, and debug log is writing a regular message. There's actually a few other messages in there as well. So you can see down here we have log error, we have log warning, log assertion, log exception, and these are all different ways we can log. So what I can do is I can change that from debug log to debug log warning. And now when I run this, so this is in my other cube controller, now we can see that we have all these debug logs with a question or an exclamation mark in a speech bubble, and then we have one with like a yellow triangle with an exclamation mark in it. And if we double click on this one, we'll see that points to the debug log, and if we double click on this one, we'll see that goes to the debug warning. So this is just a helpful way of being able to, if you've got multiple scripts printing out debug messages, to easily visualize them. Another thing which is really good is you can see up in the top right corner of this window, there is a thing with a little, the speech bubble with the exclamation mark, the triangle with an exclamation mark, and a circle with an exclamation mark. And this allows me to filter the messages. So if I only wanted to see warning messages, so things which are printed by debug warning, I can click the other two off. And now you see we only have the warning messages. Likewise, if I only wanted to see the information, so the debug.log, I can uncheck the other one so that we only see that. So that's just something that I've found very helpful in trying to sort of do this debugging, that you can comment and hide stuff that you don't want to see, especially if you've got multiple scripts which are printing stuff out all at the same time. All right. So scripting is done by default in Visual Studio, but other editors can be used, and scripts are attached to game objects. So we've seen these game objects over here as components. So we have a my cube controller component, we have a my other cube controller component, and then we have some components that Unity provides, so a cube mesh filter, or a mesh filter, a mesh renderer, a box collider, and so on and so forth. So these would be scripts. If you download the Unity source code, which I think parts of it are available to get, you would see that these are scripts just like the ones that you would write. They're just bundled by default with Unity, and they have different icons and stuff that you can, I believe you can change those as well if you want. So if we open up these two links I've got in here. So here is the Unity game object. So every script that you write has access to the game object, and it has a bunch of properties, so a bunch of variables. Is it active? What layer is it on? Does it have a tag, etc.? What's its get its transform? Then it has some methods, get component, so get access to a component, and so on and so forth, that we'll be looking at in a minute. That we can call if we want, and has some static methods, which are methods we can call without a specific game object in mind, but we're not going to worry too much about those. But we'll come back to them in a minute. So we have game objects. The game object is the thing over here and the thing that the script is attached to, which we can access. And we also have the component as well, which is basically the monobehaviour that everything inherits off. So component is a base class for everything attached to game objects. So we can, because our code is a monobehaviour, and it's a little bit confusing that there's a monobehaviour and a component because they're basically the same thing. But they basically provide a bunch of methods that we can call or methods that get called for us, and so on and so forth. Again, we'll come back to all of this in a minute. So components completely control everything which happens to game objects. So a game object is just an empty nothingness which has a position in space, and it's really all the components which make it special. So a camera component makes a game object turn into a camera, or a light component makes a game object turn into a light, or a mesh filter, a mesh renderer make an object turn into a 3D model, and so on and so forth. Oh, sorry. I think I'm fighting off the early stages of a cold at the moment, so you have to excuse me. So I've already talked a little bit about C#. So C# is a spiritual successor to C and C++. And it's very similar to Java in processing. So, the fact that we've done processing now, hopefully a lot of the stuff, there will be differences, but hopefully for the most part, a lot of the stuff will be fairly easy for you guys to sort of pick up. So as I mentioned, C# was created by Microsoft, and as such, they have a C# programming guide, which if you want more information, you can go to, and it will talk about all the various bits and pieces that C# has to offer. So C# wasn't specifically done for Unity, obviously. C# is a language that Microsoft made as part of their sort of programming thing. So the good thing about it is, even if you guys go on to jobs, programming jobs where you never use Unity, C# is actually a very popular language for a bunch of other things. So it sits on top of what's known as it's accessible through what's known as the .NET framework, which is Microsoft's framework that basically runs everything. And so if you can program C#, all you have to do is learn a little bit about the .NET framework rather than the Unity framework, and suddenly you can write Windows applications and all that sort of stuff as well. So learning all the stuff you learn in C#, don't think of it as being specific to Unity. C# itself can do pretty much everything. It's supported by every platform you could imagine, basically in one form or another. So we're not going to go too much through the programming guide, because hopefully the time we've invested in processing will, a lot of it will carry over, so you guys should be good there. But there is, you can consider this the reference in the same way that there was a reference on processing, so it's got lots of information about how to do various bits and pieces. And likewise, they of course have tutorials, because Microsoft has a vested interest in people using C# because it's their language and it's built on their platform, and Microsoft just wants people developing on their platforms. So there are a bunch of tutorials which are available that you can go through and learn various bits and pieces, and all of these you can actually write in your Visual Studio Community editor that you've got with Unity, so you can actually, despite the fact that Visual Studio Community is what Unity uses as a programming thing, it's actually its own programming environment as well. So you could actually create a new solution, which is a new project effectively, in Visual Studio Community, and you could actually start writing your own Windows applications completely separate from Unity. So despite the fact we've actually got we've actually got we've actually got Visual Studio Community as part of Unity. You can see we can use it for doing multi-platform applications. We can build applications in iOS and Android and .NET, so that'll be running on Windows and stuff. You can build cloud, Mac, tvOS. So it's actually its own completely separate thing, but we're going to be using it as a focus, as an editor for Unity, because Unity doesn't have its own code editor. Okay, so when we looked at the script here, you can see here it has two functions provided for us by default. It has a start function and it has an update function. Just like how in processing we have a start function and we have a draw function. But if you remember, in processing there was actually a whole bunch of other functions, so we could do things like on mouse down, on key down, or no, mouse down, key down, and all those other functions for detecting if there was key presses and stuff. And in the same way, Unity provides a ton of extra events that each of your scripts can tap into if you so choose. And they are known as the script life cycle, or the execution order, script execution order. So this is a little diagram which shows all of the different functions that you may choose to use in your scripts. So you can see there is a ton of stuff in there, and depending on what you're doing, it may or may not be of interest to you. So the ones we've seen before, under initialization, we have a start function. So start is only ever called once for a given script. And if we go down to game logic, you'll see there is the update function, which is called multiple times per frame. But you can see there's a whole bunch of other functions as well we might like to call. So for example, we might be interested in some physics simulations. We might want to know when two objects collide with each other. We might be wanting to do some GUI rendering, so we could call the onGUI function, which is called when Unity is ready to draw some GUI on the screen. Where else? Input events, so we have on mouse, so we can check to see if the mouse has been pressed at various points in time. So there's a whole bunch of other stuff in there, and there's a whole bunch of different, a whole bunch of explanation of what the various functions do. Most of the time, you probably will only use a handful of these things. So things I use regularly: awake, on enable, start, fixed update, maybe on trigger, on collision, yield, wait for fixed update, on mouse update, maybe the yield things, late update. Barely ever use any of the scene rendering stuff. Barely ever use on draw gizmos. Don't use on GUI much, because Unity, that's for the old way of when you're scripting your GUIs, but these days you can do it in the editor. And maybe the on disable and on destroy. So, for somebody who uses Unity fairly often, I probably use maybe half of these with any regularity. So don't worry that there's a ton of them for what we're going to cover in class and what you're going to be required to do. In the assignment, you probably can get away with using 3 or 4 of these tops. But let's have a look at some of the other examples. So on enable, for example. And the good thing about this as well is that with Visual Studio is that it has auto completion. So for example, if I want to do the awake function, it knows I get void AWA and that's in there, and if I hit enter, it will fill out the rest of the thing for me. So it's quite nice. On enable called. So let's put, just going to comment out that update function, so we can see when these various things are called. So this is on my other cube container, and just to not confuse ourselves, I'm just going to get rid of the other cube controller, sorry. We're going to get rid of cube controller just to not confuse ourselves. And we're going to run this now. So we'll see we've got 3 functions. Awake gets called first. So awake got called first, and then on enable got called, and then start got called. The fact that that just happens to be the order they are in my code is irrelevant. If I move these down, it won't be any different. What this is actually related to is if we go back to this thing, we can see the very first thing which gets called is awake, and then on enable. Then if we had a reset method, it would get called, but otherwise it's gone on to start, and then it would continue on down that way. So you can see that it's called these 3 functions: awake, on enable, start, awake, on enable, start, in the order which is shown in this diagram. But there are some other things going on here as well. So awake and start are functions which are only ever called once. We can see though that there is this line between onDisable and onEnable. And what that means is that onEnable is actually a function which can get called multiple times. So if we look over at my script over here, we'll see that it has a little checkbox next to it. And that checkbox basically allows me to enable and disable a script, which means that it will cause it to run its functions or not run its functions. So if I click on that, the script is now disabled, nothing's going to run. So if I had an update method running on that script, it wouldn't run anymore. If I click on it again, it will become enabled, and you'll notice that onEnable called is written down here. So every time that script becomes enabled, that onEnabled called function will be called. So that's one of the things about onEnabled call. Just to show you, if you remember, if I run my script or run my game as per normal with that script attached, we'll get awake, onEnable, start called. If I disable that and then hit run, we'll see that awake called gets called, because awake called always gets called for every script which is attached to something, but onEnable hasn't been called because the game object isn't enabled, and likewise start hasn't been called because the game object isn't enabled. So awake will always be called, but start and onEnabled, then everything else won't be called if that isn't enabled. But if I click on it now, we'll see onEnabled called gets called, and start will get called finally because it's become active. And likewise, if I did put in here my update method, put that back in and run that, we'll see awake gets called, and then when I check that, we're going to start getting our update methods again. And if I uncheck it, it will stop calling update because that script is no longer enabled and it's not doing anything. And likewise, we have an onDisable method, which we can override if we want to know when the script has been disabled. So enable will tell us when it's enabled, disable will tell us when it's disabled, and things will only run, apart from the awake function, if the script is enabled effectively. Cool. Pardon me. Start, onEnable, update, onGUI is one that we're going to look at a little bit later when we get to the GUI part of the course. But basically, because Unity is a 3D game engine, usually we don't want to draw our GUI until after all our 3D graphics and everything's been drawn, because the user interface should sit on top of everything. And so on GUI, you'll notice if we go back to the website, is way down after scene rendering. So we do all the rendering, we draw our stuff, and then on GUI gets called almost at the end of frame. So end of frame is when it's ready to put everything to the screen, and on GUI is basically the last thing that gets called, so that when we draw all our user interface elements, they all appear on top of everything. OnDisable is the opposite of onEnable. OnDestroy is the only one we haven't touched on yet, so if we put that in. Oops. So just put in an onDestroy method. And if we run that, so here's my cube controller. So if I enable that, we'll see onEnabled start. Turning that off and on will call onEnabled. But if I want to call onDestroy, what I have to do is right click on that and go remove component, and then you'll see onDestroy gets called. So onDestroy only gets called when a component gets destroyed, gotten rid of. Or in fact, it will also get called when the game stops running, because it's run and now it's being destroyed. Or the other time it will get called is if I delete my cube. So if I delete my cube, you'll see onDestroy gets called. So destroy gets called basically whenever the script gets destroyed. So if I remove it, if I delete the object that it's attached to, or when the application finishes running, in case I need to clean up some memory or whatever. Okay, does everyone that makes sense to everyone, the sort of various functions and stuff you can call? We'll look at some of the other ones like input events later on. Yes?
So were you using
So you'd use awake if you wanted to run some code before the start method, or you wanted to run some code whether the game object was enabled or not. So maybe it's something like setting up some bits and pieces, and you want it set up even if the game object hasn't been enabled, so that when it becomes enabled, everything's ready to go. I'm trying to think of an example, but I'm drawing a blank. So yeah, it is one of these things that you may never use. Yeah. Yeah, it's not something you may ever find the need for. I guess the reason and in fact you'll notice I haven't included it in the common events, it may be that one day you're working with two scripts and you want to make sure that, so you know, if we had, okay, so we've got my cube controller and my other cube controller here. My other cube controller start called, and my cube controller, oops. Okay, so I have these two scripts on here now. Actually, hold on, let me comment out the update method on that one. One called my cube controller and one called my other cube controller, and they both have a start method. One prints out my other cube controller and the one points out my cube controller. If we run this, we'll see we get my cube controller, my other cube controller printed out. So this one here, my cube controller, has run before my other cube controller. However, I can actually move this one up, and that will change the order such that, actually in this case it didn't change the order, which is slightly unpredictable, and I guess possibly illustrates my point better, in that having two scripts on the same game object, or even having two scripts on separate game objects, we can't guarantee when one's going to call, or which one's going to be started first. And if I have something like my cube controller, let's say we have let's go. I'll explain what I'm doing here in a minute, because it actually brings up a good point, or an interesting point rather. Let's just double check that works first. Okay, so what we've got now is we've got my other cube controller, and that has a variable called MCC, which points to a my cube controller. And in the start method, what that's going to do is it's going to print out the value, this my cube controller's object, A. And if we look at my cube controller, it has an integer called A in it. So basically what this is going to do is we can set, for my other cube controller, which is this one here, we can basically say we have a variable of type my cube controller, or sorry, an object of my cube controller called MCC, and I want to print out the value of that MCC's A variable. In my cube controller, we have this integer called A, so it's a public integer, so it's accessible to other scripts, and in the start value of that, I set its value to 5. So in my other cube controller, if I basically point this one to that one, what is MCC.A, what's the value going to be at start? So by default, it's 0, but in the start method, it gets set to 5. So if we run it, in this case, it's printed 5, but if I took my cube controller, and attached it to a different game object and changed the order of things in the hierarchy, oh, that's still 5. It's a better work. Okay, so it's still 5. So, but there's no guarantee that it is going to be 5. Like, until the start function has been called, this value is 0. So if this function here gets called before this function gets called, the value will be 0, otherwise it'll be 5 if it gets printed after. Does that make sense?
Yeah, I'm thinking about where you went.
I guess we have two objects. Object 1 and object 2. And this one has an A which equals 0, and this one has a print A, and this one has A equals 5. And the problem is that we have no idea as these are running. So if this is the start method here, sorry, thank you. If this is the start method here, if this one runs first, the value of A will be 0. But if this one runs first, then it sets the value of A to 5, and when this one runs, A will be 5. So this could print 0 if this one runs first, or it could print 5 if that one runs first. And we actually have no way of knowing at any point in time which is going to run first. So what we could do instead is change that from the start function to the awake function, because we know awake always runs before start. So in that case, we know that the value of A by the time start gets called is going to be 5. There is no way that that could ever be 0, because this function will have always run first before this. So awake will get run on every script before start gets run on any script.
Yep, yeah, I got it.
Yep, cool. Does that make sense to everyone else? It's a bit of a sort of edge casey sort of thing, but yeah, worth knowing. Okay, so that's actually brought me to an interesting point, kind of, and that is variables in Unity. So we have seen in processing we might do something like int a in a class, and that's basically saying that that class has an integer called a. We'll set its value 0 in start. We set its value to 5. And if we have, let's put in here debug log a is plus a. So print out the value of a. And that's in my cube controller. So let's just get rid of my other cube controller. Okay, so we've got my cube controller here, and it has the script in, it has an integer called a. In start it sets the value of a to 5, and then in update it prints out the value of a. And as expected, it will just print out a is 5 over and over again, because we've set the value of a 5 in start, and then we're just printing it out. So if we wanted to change the value of a to test something out, say it's the speed that something's moving or whatever, we'd have to go in and edit our scripts, and it can be quite tedious. But Unity actually has this really nice thing that for variables which it knows how to, if we make them public, and I go back to my script again, you'll see now my cube controller has a script, but a is actually now appeared underneath that. And if I run this now, we'll see a is currently at 0, now a is at 5, and it's printing out a as 5. But what I can actually do is I can change that to 10, and now it's printing out a as 10, or whatever I want the value of a to be. And so I'm actually changing the value of this a inside the script without actually changing the script at all. I'm just editing it in the editor. And what's kind of nice about that is that it will also store it. So if we get rid of this a equals 5, so if we run this now, it'll just a is 0 here, and it'll say a is 0. But what I can actually do, if I'm not in play mode, if I'm just in edit mode, I can change the value of a, and then when I hit play, we'll see a is 10 straight off the bat. And if I save this as scripting example, and then I open a new scene and do some stuff in my new scene, and then I go back to scripting example, you'll see A is still 10. So it's actually saved the value of A even after I've gone away, and if I run it again, you'll now see A is 10. And the other thing, which is the other reason that's really handy, is perhaps I want two MyCube controllers because I have two cubes. And I want the value of this one to be 15. And now if we run this, we'll see A is 15, A is 10, A is 15, A is 10. So we actually have two scripts which have two different sorts of behavior, but I actually haven't had to write the script twice. I'm using the same script, and I've just changed one of the variables in the editor, and now those two scripts are behaving differently. One is printing out A as 10, the other is printing out A as 15. Which is actually super handy because what we can do, so if you remember we had our example before, or once upon a time in processing. I don't know why it always puts them in random places. We had our example in processing of our, put the camera here, camera object align with view. We had our example which had the two cars which drove along. So if we wanted to do something like that, so my cube controller, instead of printing out the value of A, I'm going to say transform dot position plus equals. Don't worry, again, we will look at what I'm doing here later. But what I've done in my update method, I'm getting the transform that of the game object that the transform of the game object that script's connected to by calling transform, and I'm changing its position. So I'm taking its position, and to that I'm adding the vector 3, 0, 0, A. So I'm moving it by A units in the Z dimension. Actually, I might make that a float. A units in the Z dimension every update frame. So if I take my two cubes now, let's just set these values very low. And I have one with an A value of 0.1, one with an A value of 0.2, and I run this. So, you know, we've recreated our car experience, but instead of having to have the code, or writing code which says that this one should be moving twice as fast as this one, I actually have the exact same script, and all I do is I set this A value at different values, and that will change the speed of the two cars. Okay, so which sort of brings us to our next example quite nicely. So every game object has a transform component. So you can see here I've called transform, which allows us to manipulate. That should really be a transform variable. Oh no, it is a component. Transform component which we can access. So this is the transform component up here, and we can access that from our scripts by just calling .transform. And you'll see transform has a whole bunch of different variables we can call on it. There's some which are more useful than others, but we can do stuff like get its position. We can get the vector of its right axis. We can rotate it. We can rotate it around a point. We can change its rotation directly. We can translate it, and so on and so forth, which we'll talk about some examples of that soon. But let's have a little look at this example here. So this is originally called Spartan controller, but let's call it Cube controller now. So in this example, in our update method, actually let's just copy this and stick that in my update method. Oh dear, that's going all weird. So I've just copied and pasted this code here. Let's get rid of this A and this start. And we can see in this update method, what it's doing is it's calling input.getKey. So again, input is a special class in Unity that allows us to measure a whole bunch of stuff. So we can measure the acceleration. If we're on a mobile device, we can see how fast it's moving in various directions. We can detect whether any key has been pressed. We can check the compass if a mobile device has a compass. The orientation, is it portrait, is it landscape? We can get buttons, so get mouse buttons or whatever. We can get keys. So has a key been pressed, has a key down, has a mouse button been pressed, has a mouse button down, has the device been touched? If it's got a touch screen, what's the gyroscope pointing at? So the input class has a whole bunch of different functions and variables we can measure. But one of those that we're using in this script is called getKey. And if we mouse over it, we can see getKey returns true when the user holds down the key identified by the key code enum parameter. So input.getKey will take a key code. So key code dot, and you can see here are all the key codes that it knows how to measure. So there's a whole bunch of random ones like joysticks with multiple buttons. But then there's keypad, there's like the various characters N, O, P. There will be the right Alt button on the keyboard, the right Apple button. So all of those are in there, and they're all under this key code class or enum. So we call keycode.a, and this will return true if the A button is being held down at this point in time and false if it's not. But in this example here, we have input.getKey keycode down arrow, so that will return true if down is being pressed. And if so, what that's going to do is it's going to add to the value of transform.position. So it's going to change this transform position, and it's going to add to that a vector 3. So a vector 3 is just an X, a Y, and a Z position. So an X, a Y, and a Z position. So it's going to add to the transform position at each update frame that the down arrow is being held, 0.1 in the Y axis. And you see here it's got 0.1F. That's just because if we have just 0.1, Unity by default will assume it's a double. So what we could do is we could cast it like we saw in processing as float 0.1, or we could have, although that's actually going to complain as well. But we also have the special way, rather than casting like this, what we can do is we can just put an F at the end, and that will say treat this number as a float. So we create a new vector 3 with the X value set to 0, the Y value set to 0.1, and the Z value set to 0, and then we add that vector to transform.position. So what that's going to do effectively is each frame that the down arrow is held, transform.position, the Y value is going to increase by 0.01. Likewise, if down arrow is not being held down, but up arrow is being held down, we're going to create that same vector, but this time we're going to be subtracting it. So this time the value of transform.position will decrease by 0.01. And then we have the same thing for the left arrow. But this time we're going to call transform.rotate. So that's going to rotate the transform. Hello.
You guys gonna take breaks soon?
Yep, just as in 1 minute.
Yep.
So transform.rotate will rotate 1 degree around the y-axis because we're creating this new vector of 1. We're going to rotate 1 degree around the y-axis, and here we're going to rotate -1 degree around the y-axis. So if we run this code again, and actually if I save it first, and let's delete one of these 2 cubes. So now we have our cube that's just sitting there, but if I push the up key, we'll notice that it's moving down, which is confusing. These should be the other way around. But you'll notice as I hold it down, we can see the Y value over here is going to decrease each frame by 0.1. Well, actually, no, it'll be, each frame will be 0.01, but it's happening, there's multiple frames per second, so it looks like it's more than it is. And likewise, if I push down, it's going to go back the other way. And if I push left, it will rotate 1 way, and we can see again that would be rotating by 1 degree per frame, but it's because there's multiple frames each time it's updating, it looks like it's closer to 10, and vice versa. If I push right, it will rotate back the other direction. So this simple little script here allows me to move the cube up and down and rotate it clockwise and anti-clockwise, just with these lines of code, which hopefully you guys will see as being part of the first thing you have to do for your assignment. Cool. All right, let's take a break there because I'm guessing Rob has something that he wants to say. So, and it's about that time and I'm getting dizzy from talking too much. So, okay. So yeah, all strips inherit from Monobehaviour by default. So we've seen that up here. And each game object has a transform component which we can use to manipulate the object transform. So the object transform is obviously this transform up here that we're editing. So any script, if any script calls .transform, it will get the transform of the object that it is connected to. So in this case, in my cube controller, we have this script here where we get the down, if we get the key, and if it's down arrow, we're going to add this. If it's up arrow, we're going to subtract this. If it's left arrow, we're going to rotate in this direction. If it's right arrow, we're going to rotate in that direction. But I can actually put that script on anything I want. So if I have my dog here and I put my cube controller on there, we've got the same cube controller on this cube as on the dog, but because each of them is calling .transform and editing the transform, it will actually only edit the object that it's attached to. So if I push left, you'll see the cube and the dog actually both rotate at the same time because they both have my cube controller attached. But if I disable the cube controller on the cube, you'll see that it is just going to spin the dog and move it up and down and so on and so forth. So again, it's quite a powerful way of interacting with objects because a script only really deals with the object that it's attached to. So if we alter that or call .transform or whatever, we can have the same script running on multiple objects and they can all behave independently in their own separate ways, even though they're actually using the same piece of code. And of course, we can make that even more powerful again. We could have vector 3 move vector and public vector 3 rotate vector. And so what we're going to do here is we're going to take this example we have here where we move by a certain amount and rotate by a certain amount, and we're going to make them public vectors now. And so if we go back to our code, we'll see that once it's finished compiling, you can see the little compiling thing down the bottom, that we will get a move vector and a rotate vector. So I can actually change these on a per object level now. So I can say, well, my cube will rotate or move by, I think we had it at 0.01 before, didn't we? My cube will rotate by 0.01, move by 0.01 and rotate by 0.01. And my dog will move by 0.1 and it will rotate by 3. And so again, exactly the same code, exactly the same script, one attached to the cube, one attached to the dog, but now you'll see the dog is rotating 10 times faster than the cube and it's also moving a lot faster as well. So despite the fact that, you know, it's the same script and everything, actually that should be rotate negative, because otherwise it's always rotating in the same direction. Yeah, despite the fact that we're using exactly the same script, because they're both calling .transform, they're going to modify separate transforms, the one of the game object they're assigned to. And because I've made this move vector and this rotate vector public, I can alter them on a per object level as well. So the dog and the cube will both move and rotate at different speeds according to how I've set up the controller on that specific game object. Does that make sense? Got some confused looks. Yeah, sorry. If you can articulate your question, feel free to let me know. Okay. All good. Okay, so that's hopefully a basic enough example that you guys can follow along. There are a few things, you know, in processing we would call, we'll just get key effectively, but or get key down or whatever it was. Whereas in Unity, that get key function is a part of the input class. So we have to call input.getKey. And likewise in processing, we would just give it, you know, the key A like that, whereas in Unity, there's a key code class. It's actually what's known as an enum, but you can think of it like a class. And it's got a bunch of variables like down arrow, up arrow, left arrow, right arrow that we can basically use to get the keys. So that's pretty much transferable directly to what we saw in processing, just the names are a little bit different. And the transform.position and transform.rotate hopefully aren't too confusing to you guys. So we're just adding a vector to the position, so we're updating it to x, y, and z. And we're calling rotate with a vector which tells it what it should rotate around. So in this case, it's rotating around 1 degree in the y-axis. Is that all good? Everyone comfortable with that? If I gave you this code and asked you to modify it, which is basically what you'll be doing for your assignment, you feel like you could probably do that? Yeah, cool. I mean, I'm not going to do that now, and certainly for the assignment, I'm not going to sit over your shoulder and do it, but hopefully if you take this, copy and paste it into your assignment and then tweak some of the values, you can actually get some of what you need working pretty quickly. Okay, so I just wanted to talk about this a little bit. This is something when we first started teaching Unity in this course, I thought this was quite useful. The longer I've used Unity, the less I actually find this stuff useful anymore, but it's still kind of worth talking about. And that's why I've drawn this little family tree thing up on the screen. So these are all classes. These are all game objects, and I've given them names like people's names because it's easier to refer to than game object 1, game object 2, game object 3. And we're going to attach some components to them as well. So this will be B controller. This will be S controller. So imagine, hold on, got to try and think of how I'm doing this. Let's call this Bob's a lecturer, Sue's a lecturer, Greg is a student, and Charlie is a student, and Alex is a lecturer. So you can think of this as a family tree, but it's kind of irrelevant really that it is. What this is effectively mapping back to is just this hierarchy relationship we see. So at the top level, scripting example would be up here. And so Bob is a game object, Sue's a game object, Greg's a game object, and Greg has 2 child game objects, Charlie and Alex. So effectively we're thinking about the example where we have this. 1, 2, 3, Bob, Sue, Greg, and Charlie, and Alex. So can everyone see how that basically maps to that? Hopefully. If you turn it sideways, so Bob, Sue, and Greg are all first level objects, and then Greg has 2 objects underneath it, Charlie and Alex. Okay, so the reason I've drawn this up is because this is a little bit weird and confusing. So in our script, we've already looked at transforms. So if any of these scripts had a transform with a lowercase t dot position, for example, which is what we just saw in the previous example, that would modify the transform of Bob, or if it was attached to Sue, or if it was attached to Greg. Calling transform will get the transform of this game object, the game object that the script's attached to. Likewise, we also have .gameObject, which will again, not .gameObject, GameObject with a lowercase g, GameObject dot something, will refer to the game object that that script is sitting on. So we have 3 lecturers here, Bob, Sue, and Alex, and if we called if we, in our lecture, we had game object dot something, it would, for Bob, that would refer to the Bob game object, or Sue would refer to the Sue game object, or Alex would refer to the Alex game object. So transform with a lowercase t, if I can spell, and game object with a lowercase g and an uppercase O, just to be difficult, will refer to the transform and the game object of the game object that they're sitting on. Okay, let's see if we can get through this. So let's actually work backwards on this. No, let's start in the middle. So if we have game object, what we can do, let's say Bob has a lecturer script and he also has a, I don't know, he's a cricketer. So if I'm in the lecture, or no, if I'm in the cricketer script, for example, and I want to check something out about the lecturer script, so say the lecturer script has in it the times that he's lecturing, and in my cricketer script, I want to make sure that he's not lecturing at the time, I would have to have, so in our lecturer script, it has something like teaching time, and in our cricketer script, it has or can play effectively, and can play needs to check with the lecturer to see what times he's teaching so it can figure out if he can play or not. So this script, cricketer, needs to somehow get access to this script's teaching time in order to check. So if we wanted to do that, what we could do, the easiest way to do this, and the most sensible way to do this, would be to have, let's make a couple of new scripts to show this. So we're talking about Bob. Bob's a lecturer. So let's create a new lecturer script. And Bob's a cricketer. So let's create a new cricketer script. And in our lecturer script, we're going to have, an int, public int. No, let's just do public bool. Teach is teaching. Make it easy on ourselves. So lecturer has a public boolean is teaching, which says whether he's teaching or not. And cricketer has a function, or in update, let's say, let's call can play. And let's create a new function called can play. And that will can do something. So in order to say whether we can play or not, we basically need to check to see whether the lecturer is teaching. Because if the lecturer is not teaching, he can play cricket. That's fine. So the easiest way for us to do that would be to have a variable, let's just call it lecturer, a public variable, and as all other public variables in Unity, that will pop up in our editor, and I can click and drag that down and store it in there. And effectively what that has done is now this lecturer variable here will refer to this lecturer script here, and so I could say can play lecturer, dot is teaching, and actually we want to say not. So we want to print out if lecturer is teaching is not true. Remember the bang reverses a boolean. So hopefully now if we run this, can play true because he's not teaching, and then if I check his teaching box, so he is teaching now, can play is false. So basically the cricketer script is actually writing all the stuff out, but the lecturer script is what's responsible for recording whether he's teaching or not. So this is the easiest way for us to have a relationship between two scripts. One has a variable which points to the other script, and in that we're just going to click and drag that script in. Does that make sense to everyone? Hopefully.
Does it need to have the same name as the other script, no?
So the variable name needs to be the same, but this could be anything we want, as long as the name of, because this is, if you remember, for a variable you have the type, and then you have the name of the variable. So as long as the type is the same as the type here. Sorry, the name of the class. I mean, because lecturer is a type of monobehaviour, we could actually say public monobehaviour lecturer, but the problem is teaching is not a monobehaviour variable, it's specific to lecturer. So in that case, we need to make sure that we've got the right one. Okay, so hopefully that makes sense. We're basically saying, in this case, we're going to have a lecturer variable, and we're just going to point that to the script, so that when we're in our can play, we just say, is the lecturer script that this is pointing to, is teaching, is that false? If so, he can play. If not, he or she can play. But it doesn't have to be that way, and this is what this slide is trying to show. So, let's get rid of all of this. With game object with a lowercase g and a capital O, that refers to the game object that script is attached to. And game object with a lowercase g and a capital O has a get component function. And what that will do is it will allow us to pass in a type of component, and it will return a copy of that component. So instead of having a public lecturer like that, what I could do, if I know that there is a lecturer game object on there, I could say game object.getComponent, and then in angled brackets, the type of component I want to get, like that. So that will return a lecturer component, which is attached to the same game object, like that. And if we run this now, you'll notice that as soon as this is finished, we've lost that public game object. It's disappeared because I've deleted it. Can play true, can play false. So calling .gameObject gives us the current game object, and calling getComponent on that with the angle brackets with the name of the type of component we want to get will give us any components of that type which are attached to the same game object. So that is one way of doing it. There is also getComponent in children and getComponent in parent, which will, for example, for Greg, if I called getComponent in children lecturer, it would return Alex's lecturer script because Alex has a lecturer script. If no one has that game object, it will return null because there are no one has that script attached. It will return null because there is no thing. And likewise, getComponent in parent. If Alex's lecturer thing called GameObject.getComponent in parent student, it would return Greg's student script. So we can access the scripts of other game objects by using game or getComponent, and we can do that based on the game object, GameObject.getComponent, or we could call GameObject.getComponent in children or getComponent in parent. We can also call each of these getComponents things also has a plural form, so I could call GameObject.getComponents. And what that will do is that will return an array. So if I call getComponents lecturer, that will return an array of lecturer objects which are attached. And there is actually nothing stopping me from having multiple lecturer scripts attached to one thing. So if I called, lecturer GameObject getComponents like that, that will return me an array of them. So I will get this will be 0, this will be lecturer 0, lecturer 1, lecturer 2, lecturer 3, so on and so forth. So I can call and get access to multiple lecturers that way. Okay, so hopefully this is somewhat making sense and following. So calling GameObject gets a reference to the game object that the script is attached to, and then we can call getComponent or getComponent in children or getComponent in parent to find a component on the same game object, on the children of the game object, or on the parent of the game object, or we can call the plurals of those get components and children, get components and parents. And likewise, if, say this has 3 children now, what's her name? David. And David is also a student and is also a child of Greg. If I call, in the script on Greg, if I call GameObject.getComponent and children student, we would get one of these, but it's not determined which one. Probably be whichever was the first child, so probably that one. But if I called getComponents and children and with student, I would get both of those 2 student things, and then I could modify them both. So that's GameObject. Then if we go down to transform, so transform deals with the position of the GameObject that it's attached to, but it also deals with the relationship between GameObjects. So if I call transform on, focusing on Greg now, transform.find Charlie, it will return me Charlie's transform, so I can move Charlie around. I could call on Greg transform.find Charlie.rotate 10 degrees, and that will allow me from Greg to rotate Charlie 10 degrees. Or alternately, I could call transform on Greg.getChild0, which will return me the first child, or getChild1, which will be the second child, or getChild2, which will be the third child. Or I can call on, say, Charlie, transform.parent, and that will give me access to Greg. So I can, just as a parent can access its children by find or getChild, a child can access its parent by transform.parent. And finally, just to really confuse things, so we have GameObject with a lowercase g refers to the GameObject the script is attached to. Transform with a lowercase t refers to the transform of the GameObject that the script is connected to. GameObject with a capital G refers to all GameObjects. So if I call GameObject with a capital G dot find, I just have to pass in a name and it will give me anything which exists in the scene. So I could have, in Bob, I could have GameObject with a capital G dot find Charlie and get access to Charlie. Or I could call from Bob GameObject.find Sue and get access to Sue. Or I could call GameObject.find Bob and get a reference to myself. So GameObject with a lowercase g just deals with the GameObject we're talking about. GameObject with a capital G refers to all GameObjects. And likewise, it has another thing. GameObject with a capital G, find object of type, is kind of the same as getComponent, just to, again, make things confusing. So I could say, if I'm Greg and I want to know who is a cricketer, I could call GameObject with a capital G dot find object of type cricketer, and that would return me Bob's cricketer script. So it's a quick way of finding all objects of a type from within a single class. So to be honest, of all of these things here, GameObject.getComponent, getComponent and children, getComponent and parent, a lot of the time you can do like a public variable and click and drag things in. There are times when it's better to do it from script, but that's not so bad. Same thing with transforms. Like you say, there's nothing stopping me from going in my script. Before we had public lecturer, which allowed me to drag the lecturer script in there, but I could say transform, lecturer transform, or I could get GameObject, lecturer, GameObject, or I could get lecturer script. And there's nothing stopping me from, in this case, let's get rid of a few of these. So lecturer transform, I can click and drag that transform in, or I could click and drag any transform into that. GameObject is exactly the same. I can drag in any GameObject I want into that. And lecturer script, I can drag in a lecturer script, or I can drag in a GameObject with a lecturer script. but I can't drag in any game object which doesn't have the lecturer script attached to it. So depending on what I'm wanting to do, sometimes it might be useful to refer to the transform of the thing, because then I can just say lecturer transform dot rotate, for example. With the game object, I can do lecturer game object dot set active to disable the game object. But if I want to access something in the lecturer script, using the actual script is probably the best. So lecturer script dot is teaching. So we can do that. There's nothing stopping us, and this is usually a better way of doing it because it makes it much easier for me to go, oh, okay, in this case, this cricketer is referring to Bob, the lecturer script attached to Bob, but there's nothing stopping us from calling GameObject.getComponent or whatever. But GameObject find object of type is probably the one which is potentially most useful, because what I could do is I could say, okay, what do we have? Bob's a lecturer, Sue's a lecturer, Greg's a student, and Alex is a lecturer. So I could say in my cricketer script, for some reason, game object with a capital G, so we know we're referring to all game objects, find object of type or find objects of type. So let's say, let's find all lecturers. So this will game object with a capital G dot find objects of type lecturer will return me an array of all lecturers, and I could go through and say for int I equals 0, I is less than lecturers dot length. So go through all of the lecturers and lecturer dot game object. Oops. Oh, I game object dot name. So this will get me a list of all lecturer game object or all scripts called lecturer in the scene, and then I'm going to, for each of those lecturer scripts, I'm going to get the game object they're attached to and print out their name. And if I run this now, actually I need to save it first. We can see that according to this, there is a lecturer game object attached to Bob, which we can see is true. There is one attached to Sue, which we can see is true. And there is one attached to Alex, which is true. And I could check all of those. So I could say, in addition to printing that out, lecturers.I.is teaching. And so I can find out, is Alex teaching? Yes, Sue is also teaching, but Bob is not teaching. Whoops. And if I hit run now, Alex is teaching true. Yep. Sue is teaching true. Yep. And Bob is teaching is false. So we can do, they are still sometimes useful, but if you know beforehand what game objects or scripts or transforms, it's usually much better to use a public variable because it's much easier to figure out what's happening, what's going wrong. But you can access other game objects and components using these tools if you need. Make sense? Hopefully. Okay, cool. With that, I want to move on to interaction. Does anyone have any questions about anything we've covered so far? No? All right. Well, let's have a look at some interaction stuff, because this is stuff which is more handy for the assignment. So in interaction, most input functions are handled by the input class. So if I look at the documentation for input, use this class to read a bunch of stuff. So the stuff particular mobile devices as well. Android and iOS devices are capable of tracking multiple fingers. So, I can tell 1 touch, 2 touch, 3 touches and so on. We can also measure acceleration, we can measure the gyro, we can measure the compass and stuff. But if we have a look at the properties or the variables for the input class, we can see the stuff around acceleration, the stuff around keys. Back button leaves app is for on Android. If you push back on your Android, should it exit the app or not? Stuff around compass, The orientation, is it in portrait or landscape? The gyroscope, some stuff that I don't know. The location, so where about the GPS coordinates or whatever, where the mouse is, whether we should simulate the mouse with touches. So one nice thing about Unity is if by default this is true, simulate mouse with touches, which means if I write something to work with my mouse on the editor, so for example I touch on that, it actually works the same as if I touch on it with just a finger, if that's true. So you can write your code to work with a mouse, and then as long as simulate mouse with touches is true, which is by default, your touches will work like a mouse. If you want to measure touches, there's a touches array which will give you a list of all touches which are happening, whether your device supports touch pressure and so on. And then there's a bunch of methods: get key, get button, get touch, get acceleration events, all sorts of stuff. So there's a ton of stuff in the input method for dealing with users interacting with your device. So be that a desktop device, be that a mobile device, there's a ton of stuff in there which maps to it. So the main ones in Unity for keyboard input is get key down, which returns true if it has been pressed since the last time we checked. Actually, let's open up another new scene. What was this? Doesn't matter. Let's throw a new script on. Let's create a 3D object cube. There it is. Interaction. Let's create a new script called interaction, which sits on my cube. And I'm going to put in the update method debug.log input.getKeyDown keycode.space. So this is going to print out whether getKeyDown for the spacebar is true on every update method. So you can see here it's false. I push space and it still says false, but at one point in time in there, very briefly, I can't even find it now, there was a true in there. If I do it again, you might, oops. So there's a true kicking up occasionally in there. So what getKeyDown is doing is it's basically saying, has this key been pressed down since the last time you checked? So it's only going to ever appear once. Likewise, getKeyUp will do the same thing. It will only print true if the key has been released since the last time we checked. So false, and that's not actually pressing anything. Oh, there we go. There is a true. It is appearing sometimes. It's just hard to see because it's popping out. Actually, what might be better is, let's say, if that is true, then print true, otherwise it won't print anything. So if I push this down, nothing happens, and I let it go, it says true. So again, only happens once. So getKeyDown and getKeyUp will only happen when it's first pressed and when it's released. If I want to check it, if it's down at the time, I can just call getKey. And now if I press and hold it down, you'll see it's going to print out true tons and tons of times. Whereas just to show, if I did just getKeyDown, would only see it once. So that's the main difference between those, getKeyDown, getKeyUp, and getKey. Those first two only happen once in interaction, whereas getKey will happen as long as the key is pressed down. And that's actually all there is to keyboard input. It's super simple. You're either pushing a key or you're not, really. So fortunately for the assignment, all you guys need to do is detect when the user presses a key and move something correspondingly. So a little bit of a sneak peek. If I wanted to move my cube to the left, I could say with the A button, I could say keycode A, and I could say transform.position minus equals. So we're moving it to the left, which will be in the x-axis, So that will move, or subtract the 1 from the x-axis as long as the A key is being held down. So if I run this now and push A, it's super fast, but there it goes. So, you know, that's 1/4 of the first part of the assignment done with 2 lines of code effectively. So it's the keyboard input is super easy to manage. Mouse input is a little bit trickier. So let us debug.log. So we have input, and you see in here there is a mouse position, and that will give us the position of the mouse on the screen. So the thing which makes it a little bit confusing though is for some reason Unity has chosen that the bottom left-hand side of the screen should be 0, 0, not the top left-hand, which is what we would normally assume it to be. Also, you can see that it measures it from the size of the window. So 0, 0 is that bottom corner. If I go to the left of that, you can see it's now going into the negatives. And likewise, if I go below that, it's in the negatives. And if I go great, so the height of this window is, I guess, 408 thereabouts, but it will allow me to continue going more than that. And likewise, the width of that window is about 660, and it will allow me to go beyond that as well. So what if I wanted to measure it from the top left? Well, fortunately, there is another class called screen, which we can get the width and the height of the screen from. So screen.width will tell us how wide the screen is. Screen.height will tell us how high the screen is. So if I wanted to know the position of the mouse from the top left of the screen, what I could do is say, let's put input mouse position.x, input mouse position, .y, but I want to have that screen.height minus input mouse position.y, and that will make a top value, so that will now be 0 up in the top corner, and that number will get bigger as we go further and further down. So you can see now that bottom part is 410. Sorry, that is quite hard to read. Change that from a colon to that. So that is approximately 0 at the top, and then as we go down, it will get larger and larger until we get to about 410, or however tall this window is. And we could also check to see if it's out of bounds by doing something like if input.mousePosition is greater than 0 and input.mousePosition.x is less than screen width. Actually, let's just do it all in one statement, shall we? And input.mousePosition.y is greater than 0 and input.mousePosition.y is less than screen.height. Only then print it out. And so this will only execute this code if the mouse position is within this window. So it won't print out anything if the mouse, so you can see, as long as I stay outside the window, nothing happens. But as soon as I move inside the window, it will start printing stuff out again. So it's one of these things that's a little bit more work for us, but you know, it's not the end of the world. Unfortunately, there are helper functions for that. So we could do rect screen rect. So rect is a class which represents a rectangle. So we could say new rect, and let's say its position or its x and y is 0, 0, and its width and height is screen.width and screen